Hey guys, welcome back to my YouTube channel. These last few videos are going to be on our final topic in advanced math, matrices. Today in matrices, I'll be defining what they are, and I'll also be giving you many examples about how it can be represented as so that we can apply it to operations. I have an example of a matrice right here. A matrice is a rectangular array of real numbers. As you can tell, it's exactly what it says it is. There are real numbers. The horizontal array is known as a row, and the vertical array is known as a column. Knowing these dimensions, we could call it a row and column matrix. Looking at this matrix, you count from rows to columns. So, I see that there are how many rows? 1, 2, 3 rows going horizontal. So it's a 3 by how many columns? 2. 2 columns. This is a 3 by 2 matrices based on what I know. When we look at this matrix, what if I wanted to find a specific number on this matrix? I wanted to find a location. Well, there is something for that. That is known as the matrix entry. I'll give you an example here. This doesn't mean 32. These are two different subscripts. This 3, or the first term, represents how many rows, and the second term here represents the columns. So, if I want to find the number that is in this entry, we go to the third row, 1, 2, 3, and the second column, 1, 2. This entry accounts for this specific location, which is 1. I just showed you a 3 by 2 matrix. Now I want to show you what a square matrix is. And you could probably guess what a square matrix is. It's a 2 by 2 matrix, or say a 3 by 3. I'll draw one for you. It's practically a square. Equal dimensions, equal rows, equal columns. It's kind of something like that. And it goes so on. 4 by 4, 5 by 5, 6 by 6, 100 by 100 matrices, whatever. I'm going to call this 3 by 3 matrix A. A equals this matrix full of 1s. I have an equation here. A plus 0 equals A. That's like saying 1 plus 0 equals 1. What this 0 is in matrices is a 0 matrix. I will introduce that to you right now. A 0 matrix is practically the exact matrix of its dimension. It could be 3 by 2, 3 by 3. In this case, it's 3 by 3. It's where all the values are 0 based on the matrix you're comparing with. Right now, I'm going to show you how to transpose a matrix. But before I do that, we'll keep this 3 by 3 matrix, but I'll just redo it. I'll add some new numbers, some more easier numbers to kind of differentiate when you're transposing a matrix, you know. Just adding some more chunk to the butt. So, we got this matrix right here. It's still A. I'm going to ask you what A transpose equals. So, when you're transposing matrices, you're practically making your rows into columns. So you're just switching it up. I'll show you right here. I'll go pretty slow. Our first row, 3, 8, 2. Let's make that into a column. 3, 8, 2. This here, it was going horizontally, but now it's going vertically. Same applies for 4, 5, 1. It's a row that turns into a column. 4, 5, 1. 9, 7, 4. It goes horizontally, now it's going vertically. 9, 7, 4. That is how you transpose a matrix. It looks kind of complicated, but it's very easy. Now that you got the gist of matrices, let's just start applying it to operations. I'll take off this transposition. We'll just use this as our 3x3 matrices. And we will begin with addition. I'm going to create another matrice. Let's give it B. B whole random numbers 1, 2, 3, 5, 6, 8, 9, 5, 2. I'm going to ask you to add this. Matrice A plus matrice B equals matrice C, perhaps. Matrice C, it's very easy. When we're adding matrices, we add from their relative location, their specific entry. So this 3 is in the same entry as this 1. This 4 entry is the same as this 2. So we'll be just adding them. What's 3 plus 1? 4. What's 8 plus 2? 10. We'll keep adding. 2 plus 3, 5, and so on. This is really simple stuff. And there you have it. Your C matrix when you add A plus B. Not only can you add, you can subtract these guys too. Let's just change it. We'll keep matrix A and B. Matrix A, subtract matrix B. Let's find our new C matrix. It's the same thing. The matrix C entry, their exact spots will be subtracted. So, there's a little run through. 3 subtract 1 is 2. We get -1 here. We have 1. Just some easy subtraction. Subtract the two matrices, your C matrix C, there you have it. Alright, we covered addition and subtraction. It's time to cover some multiplication right now. So, what if I wanted to multiply matrix A by 2? Well, it's very simple. I'll just erase this A right here. I'm practically multiplying every single location on the matrix by 2. So, as a result, let's say our end result would be a B. My B matrix would then equal all of these entries times 2. I'll just run through this very quickly. We know our multiplication very well, hopefully. This is what our B entry would equal. This is how you multiply a matrix from at a scalar quantity. Now, if we're multiplying two matrices, not just this whole number right here, it gets much trickier. I'm not going to use this matrix because it's quite the pain in the butt. It's fairly complicated, but with some explaining, it will work out. When you're multiplying two matrices, it's good to remember that you can't just multiply any of these values randomly to get the same value. That's not how it works. Reason being is because you not only multiply, you add and subtract. So, from here, our value would be 1. We'll be multiplying 1 with the first row entry here. 1, our top. It's practically 1 times 1 equals 1. We're on to the next number in column 2. Column 2 will correlate with row 2 of this second entry. So 2 and 4, which will equal 8. We'll be adding these numbers, by the way. We could subtract, but we don't have a negative number. For 3, this is the third column right here. It correlates with the third row of this second entry. 3 and 2, we get a 6. Now, we're going down. We're on row 2. Row 2 is really no different from row 1 in terms of your procedure. 4 correlates with the top of 1 because it's in column 1 right here. So we get 4. 3 times 4, second column, second row, we get 12. Now we're adding 4 times 2, which is 8. Our grand answer comes to 15 and a 24, I believe. That is how you multiply two matrices. So, to review, we learned what a matrice is, and we also learned how to do some operations with it, such as addition, subtraction, other types of multiplications, along with seeing it in many different variations, seeing matrices in many different ways. You're probably wondering, why is the matrice so important? Well, in real life, we use it for coding, and it's much faster for computers to code rather than us, and it kind of takes off our workload. So we're kind of learning more about matrices. Tune in next video. It will be our last, unfortunately. We will be looking at inverses, determinants, and different rules that we can do with matrices. And I will unfortunately end our video today. If you liked the video, please smack that like button, and peace out.